This is a review and a recap of Lesson 12 on writing and graphing systems of linear equations. You're either watching this lesson prior or this video prior to me teaching, or you're watching it afterwards. In either case, I want you just to pay close attention to some of the key points that I'm trying to make, as well as some of the procedural ways that I solve these equations. So let's get started. We started the lesson with a warm-up, math talk, a possible mix. And what I asked you to do is just take a look at the graph. And also I read out loud the following scenario. Diego bought some raisins and walnuts to make trail mix. Raisins cost $4 a pound and walnuts cost $8 a pound. He spent a total of $15 on both ingredients. So what he did was he bought a combination of raisins and walnuts. And the raisins, so together, when he got to this checkout, he spent $15. So we don't know what combination he made. And if you look at the graph, they're asking you, could 4 pounds of raisins and 2 pounds of walnuts be a possible combination that he could have bought? So you look at it and you go, well, that means if I bought 4 pounds of raisins, and each pound is $4, so 4 times 4 is 16. And then if he bought 2 pounds of walnuts, and each pound of walnuts is $8, well, 2 times 8 is 16. And if he bought that means together this cost $32, but he only spent $15. So no, this doesn't work. So I could do it that way. But I'm also going to ask you to think back to when we did the lesson, I believe it was lesson 7, where we looked at graphs and we looked at points on the graph. And we remembered that if a point sits on the graph, then that is an ordered pair. And that ordered pair fits into an equation of x and y that equals something. All right, so I just want you to remember that. So 2 different ways, right? All right, so let's take a look at this one. Same scenario. We've got a combination of raisins and walnuts, and there's the same price, $4 a pound and $8 a pound, and he spent $15. So in this situation, he bought 2.25 or 2 1/4 pounds of raisins and 0.75 pounds of walnuts, which is 3/4 of a pound. And I want to know, is that a combination? So again, if I didn't know, I know, well, if I go $4 a pound, and he bought 2.25, and if I multiply those 2 together, I'm going to pull out my calculator, and I'm going to go 4 times 2.25. And you're going, okay, well, that's equal to 9. And then $8 a pound, and he only bought 0.75, so I'm going to go 8 times 0.75, and that's $6 that he spent. And if I add these 2 together, wow, that's 15. Well, that's perfect. However, that's one way to solve it. But take a look. I could have also read the graph, and this point is sitting on the line. So either way is totally fine. Yes, this is definitely a combination. So again, 2 different ways of being able to solve it. You decide your reasoning as to how you came up with the answer. All sorts of strategies. Either way is good. Any way is good. All right. So now let's go on and let's take a look at this situation. Same situation. In this situation, we've got, again, Diego buying raisins and walnuts. And this time, I've got a graph. And note that the graph is red this time. Same, and in this one, it's blue. It's green. And let's see what the situation is. Still $4 a pound, $8 a pound. So same situation. Spent $15 on the ingredients. So what we want to know is, can we write an equation that represents the constraints or the situation where we've got X and Y? Take a look. X is raisins and Y is walnuts right up here. So what do we know? Well, we know that raisins are $4 a pound, and I know that walnuts are $8 a pound. And I know, what did he spend? He spent a total. So when I add these two together, I've got to get to 15. All right, so if raisins are X, and walnuts are Y. So I can write the equation. 4X plus 8Y is equal to 15. And make sure, if you're in Desmos, that you hit submit if you didn't do it the first time around. So, pause, think. How did I get that? $4 for every pound of raisins on the X. We were told that it's pounds of raisins. So what does the X represent? Pounds of raisins. What did the Y represent? Pounds of walnuts. What does the 4 represent? That's the money he spent for every pound. And the same thing here. This is the money he spent for every pound that he bought. All right. So now let's go on and look at the next slide. So again, same situation. Diego's buying raisins and walnuts. We wrote an equation. It should show up right here. So the equation that we bought was what? The equation that we wrote was 4X plus 8Y is equal to 15. It should show up on your Desmos slide. My fingers are crossed that it did. All right, so now we're supposed to complete the table. We want to see, remember back here where we needed to figure out if this combination would work? Remember here, did this combination work? Well, now what we're going to do is we're going to look at a series of combinations. And I want you to use the graph or use a calculator to help you out. All right, so I'm just going to give you a minute to read through. I'm going to be quiet. I'm going to turn off my recorder. So the beauty of Desmos is that Desmos gives you the opportunity to use the graph to help you figure out this table. And if you hold your mouse over or you use your trackpad to hover over points on the line, it'll actually give you an ordered pair. So I love this ability of Desmos to do this. And because I am not working within Desmos right now, I'm actually working within a different program. I can't show you using this program what Desmos does, but I will show you in class tomorrow or when we do this lesson or if we did this lesson. So that is one way to do this problem. So if you did that, you would have gotten that all of these values here check off correctly as 1.75. This is 1. This is 1.25. This is 1. and 0.375. And this would all self-correct for you. But you could also take, if we know that raisins is X and walnuts is Y, I could also go in and substitute in my equation the values for X and the values for Y, and then solve. And if I right now were to go in and put in the combination of 0 and 1.875 for X and Y, it would equal 15. And if I didn't know it, what I could do, and I'll just demonstrate really quickly, but I think that this is the tedious part of mathematics that we don't want you to spend time on. What I want you to spend time on is being able to read a graph and being able to determine the information from the graph. Use the tools at your fingertips. That's why we're using them. And it makes it easy. But you also have to understand that the coordinate plane is made up, like right here. This is an X and a Y. And I can plug those values of X and Y into the equation and make it to see if it's true or false. All right, so let me just pick, I'm going to pick this right here. Let's do this one right here. All right, I had no idea what X was. I didn't know how many pounds of raisins he bought, but I know that he bought 1.375 pounds of walnuts. All right, so I'm going to substitute. This is a Y value. So I'm going to go in and I'm going to write 4X plus 8, and we know what the Y value is. It's 1.375. And we know that the right-hand side is 15. I'm going to use my calculator, and I'm going to multiply 8 times 1.375. I got 11, and now I still know that it's equal to 15. I'm going to continue, again, solving equations. Remember, we did this in lesson 8-9. I'm going to subtract 11 from both sides. And when I do that, 11 goes away. I'm going to bring down the 4X, and 4X is equal to 4. I'm going to continue to solve, but what do? I'm going to divide both sides by 4, and I get the value that X is equal to 1. X is equal to 1. So again, I could have done it that way. It's a lot more work, more arithmetic, more plugging in, substituting, doing all of that. And you are more than welcome to do it that way. And you can actually confirm each value here. Either way is perfectly okay, and I want you to be okay with that. All right, so moving on. 2 different ways, using your graph, using your equation. So we figured out these are all the possible combinations that sit on this graph. So 0, this means this is 0 and 1.875. This is 0.25, so it's probably about right there, right? And I can go all the way down, all of those points that sit on the line. All right, moving on. Now, take a look. Same graph, same equation, but now we've got a different situation. Okay, so now we have a new situation here. So we're still talking about Diego and buying raisins and walnuts. And the raisins still cost $4 a pound, and the walnuts still cost $8 a pound. All right, and I notice that I really don't have anything on my X and Y axis anymore. So I just want to point out, these are the things that I tend to look at. All right, so I don't have anything here. I know that this is X and this is Y, which I think is interesting. Okay, but I do notice that we've got this orange graph. All right, I've got that. All right, so here's a new piece of information for us. It says he bought a total of 2 pounds of raisins and walnuts combined. So he bought a total of 2. So when I figure out raisins, and I'm just jotting this down, and walnuts together, he bought 2 pounds. Okay, so just think about that, right? Think about it. If he bought a total of 2 pounds, well, he could have bought a pound of raisins and a pound of walnuts. Perfect. He could have bought, there's all sorts of combinations, right? He could have bought 2 pounds of raisins and no pounds of walnuts, or vice versa. He could have bought no pounds of walnuts or no pounds of raisins and 2 pounds of walnuts. So again, just knowing, right? So then we're still talking about that raisins, this first paragraph, take a look, okay? So that hasn't changed. But now we come down here and we're told something else. So instead of spending $15, we are told that he bought 2 pounds of raisins and walnuts combined. So now we're supposed to write a new equation. New. Okay, not the old one, the new one. And we're supposed to write it based on this situation. All right. So remember, up here, I just want to refresh your memory. Remember up here, our equation was 4x plus 8y. And that is equal to 15. That's what we did up here. All right, so that's just a remember. Right now, we've got a new piece, 2 pounds raisins and walnuts. Write a new equation. So we're supposed to let x be raisins. Okay, so this is still raisins. Good, good, good. So I'm glad they told us. And y is the pounds of walnuts. All right, so he bought a total of 2 pounds combined. So we don't know how many pounds, right? So how about if I say x plus y is equal to 2? Right? We can do that because it's a brand new equation. So I just want you to think about that. That makes sense, right? It has nothing, it's something that's in addition to. So now we have this equation, okay, which represented this situation. And now we have this equation, which represents a new situation. All right, perfect. All right, this is correct. And if you hit submit, it would tell you you're correct. All right, so now, I wonder if this equation, I bet it does. All right, take a look. Table again, right? Remember the equation x plus y is equal to 2. And remember, you can use the graph to help us figure out. So now what we're going to do is we're going to look at filling in this table. And again, I'm hoping during class you will see how we are able to use the graph to fill in the table. And again, remember that if I wanted to, I could actually substitute. This is really nice. X plus y is equal to 2. I could actually put in right here, if this is x and this is y, I can go in and do all these substitutions, right? Let's do the first one together just real quick. If I say that x is 0, 0 plus y equals 2, what does y have to equal? Y has to equal 2. So right there, and this is correct. All right, so we can continue to do that, which means I need a calculator, which means I need to use the procedural math, or I can simply have used the graph. So this is where having Desmos open is really helpful. So I'm going to go ahead and use the graph, and then I'm going to fill in the rest of the table. Okay, so what I did was I went in and I just showed you all these points on the line, and then what I did was I filled in the table. And so take a look here. All I needed to do is make sure that these two values, when I add them together, equals 2. So 0 plus 2 equals 2. Oops, I forgot to add this one. 1.75. So 0.25, or if I have a quarter and I add $1.75 to it, I get $2. All right, but if I want to look at it that way, or 2 pounds. So all of these numbers, when I add them together, equals 2. So that's the big thing that you needed to note. And please, I hope you use the graph. And if you're on Desmos, you will see that the graph gives you all of the points that relate to this. So the only one that I question is down here, 3 and -1. I mean, I'm not going to buy -1 pounds of walnuts, okay? But they threw that in there just to kind of show you how to read the graph. All right, so let's go on to the next slide. So now what I've got here is I've got this ginormously big graph. And basically, these are the two lines that represented the two situations. All right, so I know the blue one had to do with x plus y equals 2. And this one has to do with the value of, I believe it was 4x plus 8y equals 15. So interesting. So those are both equations. Well, yeah, and I'm kind of wondering some things about this. And I noticed that they've got all of the nice little amounts down at the bottom, that raisins are still in pounds and walnuts are still in pounds. All right, perfect. All right, so now let's go on and look at the next slide. Okay, the next slide says, Diego spent $15 and he bought exactly 2 pounds of raisins, which we know that. So how many pounds of each did he buy? So we got to make sure that it works, right? It's got to work. It's got to work in both equations. Because if I go back and I look at this equation, so he bought 2 pounds, but he also, spent $15. So I've got to figure out what is going to work in both. How many pounds of raisins did he buy, and how many pounds of walnuts did he buy? And what do you think? Could I look at the previous slides? Could I look and figure out what he did? Well, I want you to look at, I'm going to go x plus y is equal to 2, and 4x plus 8y is equal to 15. And according to the slide, and I think I don't have the right slide in, the slide should have given you, this slide should have both the lines on it. So I'm going to draw that in right away. So I went ahead and drew in the graph that should have shown up. It showed up in our lesson. So on slide 12, it showed up. And basically what I'm looking for is this point of intersection right here. And this point of intersection is where both values sit on both equations. So this value is 0.25. So x is 0.25 and y is 1.75. So this means that 0.25, remember that's the x, this is the y, so I'm just reading the ordered pair, and 1.75. And this is correct. So I'm looking for where does this line intersect that makes sure that that means that ordered pair is a solution to both equations. So right here, if I put in the x of 0.25 and 1.75 in both equations, it's going to work. And I'll prove it to you, right? So if I go 0.25 plus 0.75 up to 1.75, I get 2. Perfect. And it should be the same in this one. 4 times 0.25 plus 8 times 1.75. This should equal 15. So I'm going to use a calculator. And 4 times 0.25 is 1 plus, and then 8 times 1.75. That's 14. Therefore, that is equal to 15. Bingo. So that means that this point of intersection is a solution for both equations. So explain how you know. The x and y value make both equations true. It means that the context, the constraints, that I can only buy 0.25 or a quarter a pound of raisins and a 1 3/4 pounds of walnuts in order for me to buy 2 pounds, but I've spent a total of $15. All right, moving on. Let's look at the next one. So, are there other combinations that'll work? Well, look back at this slide. I don't see any other points of intersection. So, no, it won't work. It won't work. Because there's only one intersecting point. All right? Moving on and looking at the next slide. So, how many possible combinations meet both? Only one. Only one. And again, go back and look at this equation. I only see one point of intersection. Only one. All right. So now, in a system of equations, when I have two graphs, two lines, there can only be one point of intersection. And that point of intersection is the solution to both equations. And this is why we love Desmos and graphs, because it makes it really, really easy for us to figure it out. All right, so exit ticket number 1. Think about it. You got a graph. X plus y is equal to 4. You've got another one. 5x plus 10y is equal to 25. What is the solution to the equation? Here we go. We're only looking at x plus y is equal to 4. X plus y is equal to 4 is this one. Tell me, what is a solution to that equation? Think about it. What point is on the line? What point is on the line? Is it all of them? Is it the points on the blue line? Nah, it's not either one of these. All right, which one is it? So I'm going to correct myself here, and I really didn't read this very well at all. So if I'm looking at the black line, right, because that is the line that represents the equation x plus y is equal to 4. And if I am looking for what is the solutions, what point or points are the solutions to the equation, it's all the points on the black line. Every single point on that black line is a solution to this x plus y is equal to 4. I am sorry for stating that. All right. So, and it doesn't tell me if I'm wrong or right in Desmos, but it is correct to say all the points are on the black line. All right. So this one, what is the solution to this one? 5x plus 10y is equal to 25. Well, all of the points on the blue line are the solution. All right, and the last one, what is the solution to the system? Right here, this point of intersection. So I hope that helped. Hopefully it brings it all together for you. Please see me during office hours if you have any questions. Great job, guys.